Hello everybody, welcome to another stream. How are we doing? So last stream we finished up on the documentation for the encoder system. For crying out loud. So I got to a point where the encoder system was getting a little bit complex in some of the logic. Like there's certain rules when you upgrade text files, so you can sort of like, you don't have to upgrade if you only add and remove fields, but you can't you can't change a data type of a field or reuse an old one with a different data type. And there's rules for binary data, which is different. There's also how the sort of configuration language worked, had a bunch of edge cases as well. So I really had to sort of think it through and design it. But now we've thought it through and designed it all. Although I did think of one thing this morning which needs adding, but it's basically all there. So what we're going to do now is just go ahead and implement everything to the... There we go. Chat set up on my laptop now. We're just going to go ahead and set up we'll finish off the parser, basically get it all in shape according to this document here. And then after the parser, so that'll be in the next stream, we can get some of the semantics working properly. And then what else? The semantics working properly, and then after that'll be all the code generation. So yeah, it's going to be good. Right, so what's any to-dos here that we can get rid of? Pack types and show min max. Oh, I don't think we've done that. Can we use VLA inside struts? We solved that problem in documentation. And the type merge, oh yeah, that one needs to be done still. How do we handle if a strut changes version? Already solved that one. We've got a version per file now. Built-in vector types, already got that. Save needs to build a new array such that the types declared are in the right order. Done that. How do we handle no upgrade? Done that. Branch name. When we use branch name, we're doing commit. But yeah, hash. With the full. What the living crap is that? Oh yeah, we've already got that documented. So that's when we're in dev mode. We use a hash or something when we serialize the files out. So we can test out the development mode changes. Cool. So when it comes to the parser, so what are we parsing? Well, it's basically, imagine a C file. It's just a C file basically, but with only type declarations. It's got a couple of additions, like extra things like root, the root directed, the root type for a file, packed, right? Just so it gets rid of all the padding. Got some built-in types like vectors and things, and it's also got this sort of bit filled packing thing which does ranges too. Yeah, that's basically it. So we're going to be extending it. Oh wait, it's got these as well, where you can have an array which is of length of a field. And this is all we're parsing basically. It's nothing too complicated. So yeah, let's carry on with that. The next thing we want to do is make an enums packable. So this is the bit filled syntax. It's on the type itself, right? You put the type that you want and then you wrap it in brackets and say that's 8 bits, please. So the enum one has a shorthand one where it just automatically uses all of them, right? Whereas we want explicit as well. So yeah, we need to do that. So let's go to packed type. Already made the adjustment, so we can do support an enum or a basic type. Our type is just a structure. And it's got a type kind on it. So yeah, we'll definitely be changing some of this stuff, but so when it comes to the packed side of things, oh, crying out loud. What am I searching for? Parse type, isn't it? There we go. So in parse type, right, we parse the identifier part. We verify it is a proper identifier. And then we try and find it in the type table. And then we skip some new lines and white space. And we check if it's a basic type or an enum. This bracket. And this bracket will tell us that it is a packed type. So we start figuring out some stuff, like if it's an enum, create the packed type and put the unpacked type in there, and yeah, figure out what the basic type is that represents it. Parse the number of bits. Then we, right, so this is where we, so if it's an enum, I think we want to do this a little bit differently. So if it's an enum, we need to parse identifiers, and then those will get turned into, so this is a parse num. So we go if, yeah, so maybe we make it a function because we are calling it twice. Wait, why 3 times? Oh, parse num is for the number of bits. Right. Okay, so this one, yeah, so 1 is min, 1 is max. So for a, right, if there's not this, and it's an enum, you can do a shorthand definition. So you can say if, else if not enum. Now all of this logic down here needs to get moved into that if statement. Yeah. Cool. So let's move that all over. Right. You look at that comma. Now this is where we're parsing those minimax values inside the pack type. We could put it inside of a function and call it twice. I'm not sure though. So that'll be basic type. So we put inside of a function, right? You're just going to be getting these lines here. This line will have to be returned on. Yeah. So we could say parse. So the reason why I'm putting in a function is because we're gonna add more code to it, an if statement, to find an enum or something. But yeah, it's gonna return a basic value, which is a union. And we're gonna say parse packed num. It's already packed num. Packed type bound. Right, it's a min or max bound. So let's see how many of these things we can do. So we need to be able to pass in the basic type. Well, there's a few things, right? The type table probably. Type table, the basic type. Hang on a minute, what did I change it a second ago? Oh, I see now. Alright, I see. Whoops. Right, I've got to be careful. Okay. So basic will be the one from the unpacked type, but when we do a parse, it will return to you the basic type that of the number that you've parsed. Is it an int? Is it a float type of thing? Right. Of course, we pass that in. What else do we need? And the reader. Text reader. Right, I think that's all we need. So we take. So that'll get set later on. Alright, let's take this with us. Get an extra line in there for free, that'd be good. So we plot this here. Let's correct everything. So there's that value. Yoink. So this is a union, it's either a float, you know, it's just a value, but it's any one of these values depending on the basic type. Right, if it's an integer, it'd be one of these two ints. If it's a float, it'd be that one. So we're parsing that out here. So we should already have a basic type. This would be the found. We should probably call this expected type. And just call this basic. So, hey Travis. Doing good, man. Doing good. It's good to see you. How are you? Yeah, man. Yeah, doing good. Yeah, we got to the point with the encoder decoder system where, you know, I was writing the system, and it got to the point where the rules were kind of getting complicated enough that I needed to really spec out the whole system just to make sure everything would make sense before I carry on, and so I would make the least mistakes when I start work on it more. So we went and built. Basically, I typed out the whole documentation, which I very rarely do these things. Usually, I kind of just have it all in my head, and I'll like think it through, and it would be like, oh, it's good enough, and then carry on. But it's required me to really think about it in depth because there's loads of different rules and things. But yeah, the whole thing's been designed now, and I'm literally just going ahead and writing all the code now for it. So yeah, it's pretty cool. Quite excited about that. Going along nicely then. I'm kind of terrible about docs myself sometimes too. Yeah. See, I've been able to go so far about docs. But yeah, it's just helped me think about it. But yeah, it's pretty cool though. So now I've got this system, or I will have a system, where it's basically a C-like file. I can declare, um, it's just basically a C file. Now we've got structures, unions, enums, and we can say that it's a target mode, like we target files. So this means it's going to be purely used for serialization to a file. And this means that you can support text or binary or both. Yeah, there's a whole bunch of complex rules that it follows and things. And it will also generate the code for text serialization. But the binary one is going to be purely done in memory. So it'll just code generate in memory structures, and it will retain versions as well. But I'm also making it support GPUs because, GPUs like to pack stuff down. So you can also put GPU there, or file and GPU, which means that you want to have basically an asset which loads directly into GPU memory. But that can't have text, obviously. That won't be allowed. Yeah, it should be pretty cool. Like, I wanted to get this right because we're going to be building some editors, and I want to make sure the assets don't are not a pain to keep upgrading, That was really awesome. Can't wait to see in action. Yeah, man, it's gonna be awesome. Yeah, it's gonna be like probably 4,000 lines of code generator though. But yeah, should be pretty sweet. I just want the flexibility while I'm developing, Like, oh, I want to make that change, but I want to keep it packed. So I can make a change and yeah. But yeah, how's your project coming along? What stuff have you been working on lately? I think I saw you post on Twitter recently. I forgot what it was now. I've absorbed a lot of information today, so my brain is yep. Done so many different things today. Still in the middle of the resource system refactor, reworking materials at the moment. Alright, that's what I saw, yeah, some new materials. Yeah. Nice. Cool. Yeah. Good old Vulkan. What's you specifically doing for materials exactly? Do you have like a descriptor set for a material? Is that what it maps to, type of thing? To the mod code, then I'm adding this point actually, which is always neat. Yes. It's good to just delete whole systems. It's pretty nice. Now I don't have to remember this anymore. So if the expected basic type is not equal to the one that we've just read, so this is where we need to say min or max. So we'll pass in a bit of a string, min or max. Oh, what am I doing? That ought to be good enough. Right, what's this one? Expected. Unpacked value is a... Yeah. What the hell is this reading like? Unpacked value is a this, but the minimum is a that. Right. Expects a float or whatever. Cool. Verify the basic value and then return. So just wire this up and then we'll make the change. So the reason why we made this function is so we can call it twice and reduce the amount of code. But the reason why we wanted to call it, move it specifically, because it did look fine, is because we're going to be adding more complexity here. So I thought it's enough complexity to the point where we need to actually break it out into a function now. So where is it, the min value thing? So range, yeah, min. So reader type table, expected basic value, and then min or max. So min imum. Oh yeah, then it's got to return the value from it. And voila. So now you parse the comma after that. Then you just call the same function again, right? And then easy peasy, max. Now, maximum. So this all goes here. Nice, so that's really condensed that, which is cool. So my concern now is if it's an enum and you haven't specified a range, the type packed min, this will obviously be 0. No, it won't. So when we've parsed an enum, we need to actually get its min and max values. So we are going to have to do that. Type packed underlying type. This will be an enum. So you have to go enum min value, and we'll be able to do that. I might call it value min. I typically like doing it that way around. Yeah, so we'll get those. We'll leave them in as compiler so we remember. But that'll be pretty sweet. And then we need to make that change inside this parse packed type bound. So the min or max boundary. Now we've got to say, well, if it's an enum, you know, you could possibly parse a string. Maybe we support both. So my descriptors are all scope based. There's global, which can update once per frame, right? Yep. There's another instance level descriptor. Set is updated per instance of the material, right? Think wood material versus metal, right? And then push constants per object, right? So you've got 2 levels with descriptors. Yeah. So the material system ties into that in the renderer, and it's managed automatically by the material system and renderer, and the rest of the engine application doesn't care about how it works. Cool. Yeah, that makes sense. That's cool. Nice. So you don't think you have a third tier descriptor set at all? Yeah, so one's per frame. I guess you could do Yeah, it says per frame. Yeah, maybe. I might want it with another scope, but it sounds so far. That's cool. Yeah, I was thinking like you might want one per level or something. I don't know. Yeah. Well, yeah. Did you see SDL3? I just read into the SDL3 GPU stuff. They actually define their descriptor sets. Let's go and dig into the source code. They define their descriptor sets purely as a kind of resource thing. SDL3 GPU, I'm going to say this as a compliment. It's not meant to be the it's not meant to be this high-end AAA GPU thing. It's meant to be this sort of like easier to use indie GPU API, but it's not so toy-like that it's crap. It makes some good assumptions, I think. I prefer it to Web GPU, to be fair. But yeah, if you look at their descriptor set design, so yeah, I think I'd just recommend this to every indie developer now who doesn't want to learn Vulkan, basically. Descriptor set layout in it. Again. Yeah. So 0 is samplers. So yes, so descriptor 0 is samplers, read-only textures, and read-only buffers. So basically uniform textures, uniform buffers. One is storage textures, storage buffers. I guess you can get storage textures in here as well, but they've got to be read-only. And then 2 is oh no, maybe not. Okay, I thought about it wrong. Right, 0 is samplers, read-only storage textures, read-only storage buffers, write-only storage texture storage buff, then uniform buffers in 2. So what this means is when the person is writing a shader file and they're using one of the 3 languages or whatever, they can simply follow these rules and then it will work fine, which is pretty cool. And then you should be able to use reflection data to help out with some of that. Yeah, so they didn't split it up on update frequency. Yeah, they split it up by just class of the type of the resource, if you will, or the class of resource, whatever way you want to say it, which is absolutely fine for indie developers, I think, who just want to probably do a 2D game with some extra fancy shader stuff. And even like entry 3D will be good enough. Hey Voodoo, how you doing? Welcome, welcome. Yeah, very traumatized, that's true. WebGPU is with their crazy decision to make a new shading language. Yeah, that's the main downside about it. I was looking through it some time on stream. I did a stream on it, and I just looked at it. I was like, they've made some pretty good decisions. I like most of it, but then I had to dig into how the implementation worked, and then I realized that they don't record directly into command buffers. So they have a concept of like a command encoder, but they really have their own. So it's not really directly, it's adding another level of indirection. But what's great about the SDL one is you actually encode directly into the command buffers. So it really actually feels like it just is a layer on top of the API, more of a thin layer on top of the API. And yeah, I was a bit disappointed that they both don't support bindless. Bindless is really cool, but most people don't need bindless. Yeah, Travis, I'm not sure how good of a way it is, practically speaking, but I think your scope way is probably much better in terms of like, um, you will not update your descriptors as much. Um, you can have the user define their descriptor sets, and and the way the update is a lot, be it scope based, isn't it? So it should be better for performance too. Yeah, exactly. But yeah, the SDL way is mainly a convenience way, I think. Yep. Uni started. We have some cool subjects. There's some graphics programming course. Awesome. Very nice. What country are you from? Where are you doing your course? Well, okay, don't tell me exactly where, but just what country? 'Cause I'm interested in Poland. Fair play. Yeah, I heard people in Sweden have it good. Um, you know, that's it's pretty interesting. Yes, if type kind is an enum, then we want to say right. Parse an identifier. So let's look for an verify identifier because I've got to do this. I could have written this code better, but I'm not doing much more parsing, so I'm just going to keep with this strategy. So this one's really looking at like a comma, maybe a space. That'll do. We get an ident. Nice. And now we're going to find the ident. So we're going to go through all the enum values. Type enum values. Right, I think there was a hashes thing somewhere. Ident hashes. Beautiful. So it can be a bit quicker. Wait, I got a thing for that. U64. Ident hash. Core string hash. Ident. Right, so that'll be a little bit quicker. So we can find an enum value. Now, found value. The address. So maybe we should do an index. Because we do an index and it might be retained. Will it though? Right, so we have the regular file, we make changes to the enum. And in the database file, we're going to merge the enum over. The enum will only get merged if... Well, those the rules. Right, so for text files, you can add and remove enums. Values. Probably because it's stored as text. But you can rename Okay. So if we have the packed type and yeah, but that changes the data type. By having the ability to add and remove enum values, and if they're used in a data type, you have literally changed. What have you changed? Oh no, you can add and remove them, but you can't reuse. You can't change the value, isn't it? Reuse or removed enum with a different name. Yes, that's right. So that means the data types will not change. If you remove one which is being used elsewhere, that's a problem. Yeah. Right, that's cool. That all works. So when you're copying it from the regular file to the database, if you use the index, yeah, that's still going to be a problem. If you use the pointer, you've got to patch the pointer. Yeah, we can still patch the pointer, but that's cool. We'll use the pointer. You just got to remember to patch it is all. Hey, Basandro, how you doing? Welcome, welcome. GS Vault. Welcome, how are you guys? Now we're going to break from there. So I do think we need another return value, so we're going to do one of those. Be a pointer to pointer. So I guess by default we can just set it to, oh shoot. Set it to null. Well, no, it doesn't matter. Because it'll be zeroed anyway, I think. Yes, so if not found value, there's a problemo. Is there? Yeah, we always want to use the um um undefined enum value with the name in the enum, something like that. And we could probably use the special syntax to be dollar value identifier, dollar enum type identifier. So we go generator format type, and then generator. Oh, that'll just be for the type one. But we actually have to do a dot star s here because this is an actual local. Nice. Cool, so I'll exit an error with a line number and all that good stuff. Yeah, so because this is not enum, we parse it as a number instead, like I was doing before we made this change. And then this will be set to found value. Cool, so let's go ahead and fix those functions. So you need to pass in the type and the address of where the unpacked enum value min. Enum value max. Yeah. Right, so that's going to work. So inside the type, we need to, for the enum value. Value min, value max. We need to get those in. And inside the enum value itself, what do we need? Well, it's just got the basic value, isn't it? Same old, fed up with managerial crap, getting ready to resign and go back to programming. Awesome. Feeling rusty as F. Oh man. Don't worry about it, you'll pick it back up. Yeah, I get what you mean. There's been, I took 2 weeks off programming and I came back to stream and it did feel like I forgot so much, but you get back into swinging things pretty quick. I know you've probably taken more than 2 weeks off. But yeah, it's cool. Yeah, well, what are you, have you got another job lined up then? What the? Ah, we didn't add these to the packed type. So the packed type. I don't know why I've called this a packed type. Do we use packed type anywhere? I don't think we do. Maybe we should follow suit. Yeah, I ain't done it. Let's follow suit with this. Inline structures. This is the way. Right, so we want to add pointers to the enum values if it is an enum. So enum value. Unpacked enum value min. Wait. Yeah. Yep, that's good. Cool. I'm glad those are in. So, hang on a minute. What's going on here? Enum value min. So if we don't specify right, so let's get back to some actual syntax here for a minute. So when we're parsing this packed type, we parse that, we realize, oh, that's an enum. And then we're parsing this, we're going, oh, they want a packed type, pack into 8 bits. If you haven't specified the min or max value, which comes after this, separated by commas, you get the min and max value of the enum itself, right? If you do specify it, shoot. Maybe you have to maybe you have to manually do it. Because if they change this by deleting a min or max value, this will change this data type. And then if it changes that data type, that breaks a rule. And that rule is if you change a data type, you've got to increment the version of the file. Right? So yeah, we can't do the shorthand one, unfortunately. Right, let's get into the docs and change that. Right, so that doc was in under the packed section. So maybe they should be allowed to put numbers in. Something like that. And maybe you can have repeats, I don't know. Hmm. If you packing numbers, it is a bit troublesome actually. Because it would mean if you change something, you change the type. And that'd be another version. But that doesn't matter for text files. Yeah, so maybe actually, no, we can keep it. This would be amazing. So we can extend the rules. The rules say, right. So you can change packed types min and max range in a text file. Because the whole point of it is to pack binary files. So for updating text files, you don't have to upgrade the version if you are change the packed type min or max values. Right, those are allowed to change. That's pretty nice. But for binary data, we'll make it explicit here, so it's not too ambiguous. But the following will require you updating the version. Change a pack type. Yeah. Cool. Right, I'm glad we've ironed that out now because that's made... We can still keep this, and we've thought about some potential problems actually with the binary one. Yeah, so this is good. Today, hey Phoenix, we're working on the parser for this custom text file. Custom encoder description file. It basically just declares a bunch of structures and enums, but it's got some few extra little features. So we're just gonna work some more on the parser. Hopefully, get some more done. Yeah, Rusty isn't borrow checker. Maybe. So this will copy over the value and the value. Cool. So I think we're okay with that now. Yeah, we've got to do a few things. We'll get back to this. I just want to make sure that we get the minimax. I don't forget the minimax value thing that we've added. So what we need to do is when we parse an enum, crying out loud, my laptop died. Get the charger. Alright, I'll get chat back up in a minute. So when we parse the enum, we parse all the values, right? So what we need to do is we need to come across a min or a max. So we need to retain it. So we go the thing is the max value is different for every type. So yeah, we're gonna have to say min value or value min value max. And then we'll have to say a pointer to the actual enum. So enum value min Now, can we have an empty enum accidentally? I think that could be. We don't want someone to declare an empty enum. That would just be weird. Hey, robot, how's it going? It's the meme lord robot. How you doing? Been a while. Yeah, maybe we should make sure that these, you know, enum value, because Whimsy enum doesn't have anything. It's a bit problematic. So type enum, we're crying out loud. It's called an E. Nothing better than E. Enum, values count. So that's equal to 0. We wanted to say enum has no values. Please add at least 1. Hint, banana bread. Can't get better than that. So we want to do that for the structure as well. We're hearing it. Strut. Yeah, there's 2 things that we didn't mention actually. It was the yeah, default values for text files. I forgot about that one. So maybe we do keep default values. What was another one that I was thinking about earlier? Unions in text files are ambiguous. So we probably need a tag condition for each field, something like that. If text encoding is enabled. And I don't really want to add tags union support because it kind of sucks. Yeah, so back to that parsing the enum thing. New question, when you have an n-type B8 n-type, does it mean, what does the B8 mean? Is it represented in enum in 8 bits? Yes. Yeah, so effectively this is just part of the custom thing, right? I wanted to have, it's a custom format. It tries to stay as close to C as possible. It supports enum structures and unions as in the same way that they're supported in C. But it provides some convenience things. One convenience thing is the bit packing. It does bit fields in a different way where you have a sort of like a packed type with a range of min and max. So it can take away the minimum value and then squish it down into 8 bits, for instance, or less, right? It doesn't have to be 8, it could be 3 bits. Well, it depends whether it fits, as long as it fits the range. It can pack down floats. It can also pack down enums as well. Yeah, this can do with less bits. You can probably do it in 3 bits, but yeah, this is, and it also supports variable length arrays. So we can have, you know, say this array comes from this field here. Yeah, it also supports something else that I forgot now. But for the most part, it's basically, let's see. Oh, it supports packing with a packed, like, directive. But yeah, so we parse up that file, we code generate text serialization and deserialization code, and we generate some types so we can do some binary packing and unpacking, and it will create some functions as well, which will automatically pack and unpack things. So as for an example, if you declare it with these bit packed things, this all fits into one 32-bit int, but it can technically overflow a 32-bit int if we wanted to, and a field can overflow 2 integers if it wanted to. But since it only does 1, all the bit fields are crammed down into there, and we'll generate these 3 functions, which will simply extract these out as the requested values within the range, right? Yeah, so that's all it's doing, because I feel like I want to be doing this a lot for GPU, but also it'll be handy for files as well. Just this is our way of compressing, basically. Yeah, so this min-max value thing, unfortunately, we're gonna have to do a bit of a switch and be like basic type class enum underlying type. Awesome. Thank you. Yeah, it's gonna be pretty sweet. I haven't seen packing stuff done like this before in other languages. I just thought this is how my code is looking, and I really want to support that first class in this system. So yeah, we're not just, this system doesn't just output for files, it also just generates packing code automatically if we just want to use it for packing. But it does also do versioning of files as well. Yeah, so it's gonna be pretty nice. Right, so here we can set up those min and max values, right? So, value min dot un equals 0, but the max. Oh wait, it's gonna be the other way around, isn't it? So the min is u64 max, is that right? What do we support up to again? Right, u64 max. Yeah, I got one of them. Shorthand. And then the max value is the min, so we can min and max, and it actually works as we parse stuff, right? So this would be signed 64 max, signed 64 min on the, and then the same thing here. This would be, floats have infinities, so you do positive infinity, negative infinity. Right, it's kind of a double though. Oh yeah, there'll be a double, it's cool. Or it'll work anyway, it'll cast or whatever it is. Cool. So now what this means we can do is take the same switch statement every single time we parse a value, which is here. There's an equal sign, so we do change the value to here. We do the operations. So we switch on the underlying type. Now we simply do a bit of, so this one you want to min u64 with itself and whatever is in enum value.un. Right, so you copy paste that, replace all mins with max. Then repeat. So you replace u64 with s64, and then float 64. Yep, then all uint with signed int then all uint with float underscore. Very nice. So that'll do the min and max thing here, bearing in mind. Oh. Wait, you can't get a float enum. Don't be silly. So what did we do? Yeah, I didn't handle that, did I? Expected a basic type. An integer type. And type. Right. Basic type class. Intrinsic type. Kind. Not equal to float. Oh wait, not class. What? Kind. Sorry. Basic. Yeah. Not equal to basic type class float. Now I do think I remembered that we've added a boolean since then, and we'll make that a uint. So yeah, I guess you could do a boolean one and that'll work. That's okay. Right, so we've added that check in there. Or is equal to a float. That's what I meant to say logically. Right, so we set up the min and max, no floats. Get out of there, that's silly. So we go parse over all the enum values. We're doing the min and max type of thing. Now, really, we should be doing if statements and stuff. But I've already written this code out now, so I'll write it out this way instead. Equal EV. So we've found the new minimum. We're going to set value, the enum value min to this current enum value. Then same thing for max as well. And I guess, right, these can just be copied outside the switch statement. Yeah. Yeah, we don't have, do we support duplicates? Yeah, we don't support duplicates. Maybe that could be a thing in the future we might do, I don't know. Cool. So all we've got to do is plug those into the enum structure at the end. So at the end we definitely need to say enum dot value min and value max, enum value min and max. Right, so now we've got those in. That packed type stuff is going to work out nicely because it does use these things, right? Yeah, it uses the min and max values if you don't specify the min and max on a packed type. Cool. Hey there, Hatem, or Hatem. Yes, Hatem. Might be Hatem. Welcome, Adam. How are you? So something I wanted to do about those packed types is I think we don't actually have a concept of min and max. Sorry, we have a concept of min and max values, but what we don't have is a concept of actually checking to make sure they are min and max. Up here, I have a bit of thing here that says ensure that max is greater than min, or greater than or equal to min. And yeah, the use number of bits actually makes sense. But that would only be for integers. But yeah, we don't have that. So let's go and put that in. So what I need to do is after we've parsed, this is where we parse the min and max fields. There's the bits, there's the parse number, right, for the bits. If we pick up the comma, we parse the packed min value, do another comma, parse the packed max value. So what we need to do is put a bit of a check. So I think we'll need to do like another one of those switch statements. I wonder where we did it. Oh, this one. So what we need to do is say, oh, bit of a lovely switch in there. So the basic type can only be a uint. No, it can't. It could be a float as well. Yeah, so we want to say if Boolean so there's a couple of things you want to check, right? Min max. And then the used bits thing, right? So is max has min max error, then the other one is like has range error or something like this. Right, so has min max error, well, if you have type packed value min as a uint, if that one is greater than whatever we've just written, yeah, they could be the same. If they're the same, then it means the field is nothing, right? They have to be different. If the min is greater than or equal to the max, there's a problem. And then the other one would be there'll be a range error, where if we can't fit it into a certain number of bits. So effectively, if you got to do a max take a min value, and this will tell you what is the biggest value, or what is the range you got to store. So given the number of bits that you've specified, so you've got to figure out like what's the most number of bits that you're using. So I guess you could do like a most significant bit. Yeah, tell me the most significant bit which is set, and make sure. So if you get the calculator out. So say if you've got a number like 1,000. Well, let's do a bit of a small one. 6,400. You get the most significant bit index, which is 12. That's what that function does. And we have a number of bits. Wait, is that bit 12? What the crap is going on here? Ah, there we go. Right, it's 12 because these ones were not showing up because of the UI. Anyway, so we parse the B. The B tells us the number of bits. So basically, if we get most significant bit is 12, wait, is that right? Yeah, so we get the most significant bits, which is 12. We've got the number of bits. Yes, you don't need 12 bits to RD. Yeah, so 12 bits can represent a number all the way up to, well, this is 13 bits, isn't it, actually, because it's bit number 12. Sorry, bit index 12. So it's got 13 bits, but that can support a number all the way up to 8,191. So we compare that to number of bits. So they said, right, I want to fit it into 13 bits. Right, so this number has to be greater than or equal to. So it's an area if it's less than number of bits. So you go type packed bits count, just like that. Cool. So you will so that's the range error. Now for the signed int, it's going to be the same thing, but obviously for signed types, so uint, we do signed int instead, so the comparison operator works all right. And so the now the takeaway was always going to work the same, but you know, yeah, when you take away two integers from each other, you always get a positive number, right? Is that right? Yeah, when you always take the minimum away from the max, you always get a positive value. So that's cool. Now for the next one, floats. Floats do not need a range check. They have, if you say you've got a fit of, if you say float 32, 3 bits, a range between from 0 to 100, it's just going to do the best job it can, and the step value is just going to be big. The precision is going to be terrible, but it'll do the best thing it can of 8 values to represent those things. Maybe I should double check that stuff. To do check to make sure packed type min max values work as expected with low precision float types, something like that. Yeah. Excellent. Right, so what am I trying to figure out now? Yeah, so I'm glad I got that in there. That was a good edge case to think about. Got to catch all the edge cases before we use it, really. Because it'll be a bit of a bugger when you've already serialized out some stuff and you're like, yeah, this is, yeah, Well, yeah, I won't have to. I could probably delete assets for a good while, but yeah, it's good to catch them all as early as possible. So now we know if we've got errors or not. We'll report the errors. So, first error. Probably join this one up on the line. This error is going to be is min-max error. So has min-max error. Right, so here we want to say the min-max value. We could just say packed type minimum value must be less than the max value. Min value must be less than max value. Yeah, I could have put the actual numbers in there, but it's sort of been a bit fiddly. Can't be bothered. You could just open up the file and have a look anyway, because you're going to have to correct it. So, I'm alright with that. Next one is has range error. This one is to do with, we've got the number of bits. We can say that. In there, I guess. Well, I could do the custom formatting thing, and we could get them to be displayed. But yeah, the range one is like we could get them to get displayed. Yeah, we'll put them in there. We'll do the extra work. So it's our custom print formatter, right? So we just go over every character and add it to the file. If it's not $1, if it's $1, we check the next two characters, and then we just do whatever the crap we want with it. T means type. F means field. V means value. So we're going to do P for packed type, and we have to do another one, which is kind of going to be like this one anyway. Packed type. So for the packed type, you can do packed type. So you've got min and max. They both start with. I guess we'll do n. I don't know. Min. And then x for max. But yeah, so you get the packed type. You get the unpacked basic type. If it's assigned int, we'll print out the type packed value min dot sint. What is it doing? min dot signed in. Unsigned in. So that'll do the min. Or make it an X to do the max. Now, so your min max, we also want a way to get the range. So we can display that in the error messages really nice. So we're doing it R. So we'll just do the subtraction here. They both actually kind of work the same. So we won't need it. Wait, they can be floats. I do not handle floats. Whoopsie. Ah. Right, so improvement. See, if you have a boolean, it will just put it as an integer, but that's okay. We're all quite familiar with that. Yeah, so I guess we repeat this. Max for min. Cool. And then repeat this one more time. Yeah, maybe we can join them up and reduce the number of lines. Make it a little bit nicer. But yeah, so for this one, we need a bit of subtraction. Yeah. So this has been unsigned. Realistically, the signed in and int should be the same. So we'll just, because it's 2's complement, you can treat an signed in as an unsigned int and do adding and subtraction, and it will work exactly the same. Yeah, we can guarantee that max is greater than min, and you'll get an unsigned value out of that anyway. So that should be what we want. Then for the float, you also want the same sort of thing, but you obviously want a float. Right, so that's that nice shorthand way of doing those error messages. Now we can just do those errors really nicely. Then parse type. If we go down just a little bit. This has min and max error range thing. So packed type min value dollar packed min must be less than the max value dollar packed max. Right, then in this range error, we go the min max value, which ends up having a range of this, doesn't fit into this many bits. Something like that, right? Pack type min max min and max. So min 4, max 7 or whatever, right? With gives a range of 3, and this does not fit into 2 bits. And this does not fit in this many bits. And you pass in the number of bits using the regular printf args. Type packed bits count. Cool, so that'll give us a really nice error there. Happy about that one. Right, so that would have ticked off. I think we've fully done the parsing now for the packed stuff. So this was the min-max values, and also make sure the number of bits used is greater than the capacity. Yeah, so I'm glad we ticked that one off. So the next thing I want to add support for is just get all the directives in. So we've done the packed type now. That's cool. Directives need to be parsed. So let's start with this one. This one is the target directive. So you put it at the top of the file. It's got to say target. Yeah, I'm targeting a file and GPU, which means that it's going to be, you know, we want to have a file which goes to GPUs and does not support binary type of thing. So we'll get this all laid out, and we'll get to verify and everything. So, right. So when we parse the file, I think it's called, yeah, parse file. Doesn't get more simple than that. So we parse the database one, we parse the encoder type table. So the database holds the information in a more persistent way. So it keeps hold of the history basically if it needs to. Whereas this one is when we edit. So so at the start, we literally just parse the target directive right away. Using the reader. So we go A. If it's not equal to, we can parse a whole string, I think, at this point. Because we're expecting there to be a space character. You know, they could use a tab character. That would be a bit weird. It shouldn't be a problem. Yeah, let's just, you know, it is invisible though. Right. So we'll be like, yeah, what does the identifier thing look like again? Yeah, read until the next space. arg1, arg2. Need 2 args. Yeah, so maybe we read until a... Alright, here we go. So parse the char. Declared directive. Found directive. Bit shorter. So we'll say if it's we'll set that to true. and it would have found directive so long as it continues to do that, which finds the hash, and then we'll keep going anyway, and we'll get it to also, after it's found that, it will skip to the next character, then we'll be like, is the next one target, right, or read until found directive and equal core string equal with a literal, read up until we find a space or a tab or a new line or something like that, and make sure you find, it'll stop on those, yeah, and then make sure that's equal to target. So the reason why I've done it this way is because otherwise we've done two if statements and probably have to use a goto or something dumb like that. So this way they will just to keep going. So if either of those fail, if we've not found the directive part, then we have a problem. No expected hash target directive. To declare what to define, to specify what type of encoding this file is for. These types are for. Yeah. So hint hash target file slash GPU binary. Maybe. Right, this shows you get slashes in it or whatever. I don't know. So after we've done that, you would be on a space, right? So this is where you want to parse white space. No new lines, just the white space. That's the thing in it. Good. So skip me some white space, please. And now we want to parse a series of slashes with a yeah, so effectively we should probably have a structure somewhere where we store these things. Yeah, I think this kind of has to change a little bit. No longer can we just have a type table. We have to have other things about the file as well, I think. Yeah, let's stick around. I guess let's just write the parsing code quick and we'll store the logic in wherever. So you've got to parse up and bit of ASCII, get the right one. Is it file GPU net? I was thinking maybe we'd call it CPU rather than mem, actually. Might be better. Mem. Alright, we'll call it CPU. Better. Right. So this is where you now specify a bunch of, I guess while it's equal to a / kind of. So it might be a do while loop, but I'll probably be, as usual, not quite wanting a do while loop. So I'm just going to do a while loop with an if statement in it. It's just better. So we'll parse we kind of want one of these. So you get a core string. Do your ident, or it's not really an ident, it's like a target. Alright, get one of your targets. We want to stop when you reach a space, a tab, a forward slash, or a new line, or a whatever, right? And yeah, so if you get, if this one failed, yeah, if this one stopped at a new line after target, this would be empty. So yeah, that'd be nice. So we then just say if target to core string equal lit target. So we're just switching all the targets here. So one of them is file. So if it's file, we'll switch on a Boolean somewhere. Then else if it is GPU, CPU, networking, so we'll just switch on some stuff basically. And then we want to say after you've parsed that, right, if you didn't get, so if you put a space there, it's a problem. We can't have spaces here. It's got to be slash separated. So you then say, right, compare a character for a slash. If we didn't get a slash, right, so if you don't get a slash, then we're just going to break here. And then we'll go around again. Hey, Matt Programmer. Thank you, appreciate it. Hope you're having a nice day. How's your day going? Thank you. Yeah, so we probably want to have an error check here as well. Yeah, so I might actually make these bit flags because it's going to make things easier. Yeah, we'll probably have like a type called target flags. Target flags file. GPU, CPU, net. If only file was 3 characters, right? Would have been nice. Oh well. Yeah, so we'll just flag it so we can do multiple at once. But I think the benefit of doing it this way is that we could do this we've got to store this flags thing somewhere, but I think we can set whatever it is. It'll probably be in this file thing. We might call it file. Like a gen file or something, I don't know. We're still going to make this structure. Target flags or equal that. Right now the beauty is wait. Local thing. Target flags. We need a none. And this way we can iterate over all the bits and things like that, you know, get some good. Right, so the cool thing is we can check to see if right, CPU then net. We can then say if file target flags and right, we get a bit of SIMD here, single instruction multi-data. Just not really using SIMD, but anyway, the original SIMD. We're checking all the bits to make sure that if there's any overlap here, it means we've already set it in the past. So we can't, you know, say GPU/GPU, it doesn't make any sense. So we can do that error. Target directive cannot have duplicate should not specify the same target more than once. Specified more than once. Nice. Right, then we parse that slash, goes back around again, does more parsing for this. So if you don't get any of these, that's another error. Right, if you just ended it on a slash, that's a problem. So yeah, so here we're expecting a target directive should not have was expecting a is expecting a target. There's two cases, right? One, the previous one was a slash. Oh, there's quite a few things, right? Target.size equals 0. There's also like an unrecognized target. That's what this one is. So unrecognized target this for the target directive. Hint. The options are file / CPU / GPU / network. I gotta go. It was fun. Bye. See you later, Voodoo. Good to see you. Have a good start to your week work, my friend. Where's all the music going? Keep going. Alright, what is this? So we want to specify integer casted target dot size and then target dot data. Cool. So the other error is that you end up getting a One is you've had a forward slash previously. The other one is you've not had a forward slash previously. So yeah, we want to check the character that is that right? The character that we're on, or the one before? If reader dot text index reader dot cursor -1 equal forward slash. I think that's right. Yeah, because you would have parsed the forward slash and then incremented. Yep. So you take one check. This will tell you that the target directive, so found a slash, expected another target to be specified found another, or found a slash, targets cannot be ended here, or something like this. Targets, the target list cannot be ended here. Either specify another target or remove the slash, something like that. We must do a hint. Found a slash. Whereas the other error is you've not specified any targets, but you found a new line would have been found, or a carriage return or something. So here we want to say you must no targets found in the target directive. The options are any of the following. Any and as many. Any and as many. The options are any and as many. That's pretty fun. The options are any and as many of the following. Bit of a colon there. That's right. Cool. Right, so I think that's the logic sorted out for this. So the top of the file, you put hash directive. You put the hash for a directive. Parse up to a space, any white space. Make sure it's equal to target. If it's not equal to, if you don't find the hash or the target, that's an error. We need the target to be there. We'll give an example. Now, so this only parses the first argument. We still got to parse the second argument, but we can do that. Yeah, so we skip the white space. That's just the spaces basically, or tabs. Then we ask to go up to the next space, tab, slash, or new line. We check to see if it's one of these file GP or whatever. If it wasn't any of those, if there's nothing in there, well, we've either got a trailing slash or we haven't even specified one. Yeah, trailing slash, or we haven't even specified a target at all. Then if not, we've got, if you do have a target, it's an unrecognized target name. Then here we're checking to make sure we don't redeclare the same thing. And then we break if we've not found a slash. Nice. So we want to do the other argument, but what I would like to do first is sort out the actual storage of some of this stuff. Realistically, we should have a gen file now because yeah, it's getting a little bit too crazy. There's going to be things in here. So there'll be a type table. There's also going to be that target flags thing. These are all the targets. There'll be another one called an encode format flags. Hey Davros. I got Blender compiling, thinking it would be nice to extend its custom UI property UI and make a better game editor, but looking at the code base is wondering why I like stronger types. Yeah, getting very triggered by seeing ID property and with type tag and being char. Yeah, their system is like, I've written some Blender plugin stuff before because I tried it for my engine. Or no, previous engines. I did the export script thing. And yeah, it was like, you know, to figure out anything, you read their documentation and it's quite big and crazy. You can kind of find the types there, but while you're programming, you can't really see the types unless you run it and print it out, and you have to run part of the code and like, yeah. Private stuff is definitely nice to have. I think what I agree with you is yeah, it's nice being able to extend Blender in an easy way. I wouldn't say if I like Python though. Yeah. Python for me is like, yeah, I don't like Python at all really. I think it's probably one of the worst languages ever designed. Maybe. I would put it quite high up there. I think I prefer Lua to Python. Yeah. But yeah, that's just my opinion. Um So the format can either be in text or binary. So you're actually gonna, so you run your own extensions for Blender, is that what you're doing? So actually put, and then you can, in your exporter, you can check for those extra fields. Oh. So in GLTF it supports custom properties. Nice. I didn't realize that. That's pretty cool. That's great. Format flags. Right. That's cool. Right, so got anything called gen file. So there's the encoder file and the encoder database file. It's cool, so it's got those extra bells and whistles in there. So when we do a parse file now, to initialize these two type tables, the others will be initialized to none, because it's all zeroed. Then we parse a file by passing in the file itself. It's got to change the prototype. So then what I'll do is I'll say gen file, whoops. Let's call that file. We'll get the type table out because it is nice to have that shorthand. Now, did I do that in a silly way? Yeah, right. Save has got to work differently, that's fine. Right, parse file. Right, so we get the type table out. Right, so we parse. Yeah, so now this works, right? We store the type flags in there and we OR it on. Excellent. So you would have had to have gone in here once at least, so that it will error if not. That's good. So the next one to do, so you would have come across like a space or a tab, hopefully. The next one to do is do it all again, this time for the format. So format flags none, binary, text. So if you've not found it, because custom formats get optionally exported, there's a tick box to enable them. And that's to compile the importer with the Rust feature flag. Okay. I just prefer to have a formal object link type visible in editor as a named line. Right. And the current option is to use the object names as strings. I see. Right, you're like a link. Right. Hmm. So does that mean if you rename it, does it automatically fix it? Like, is the link with another thing rather than a name? Um. Right. So after you've done those, this switch activates that door type of thing. Yeah. Um. Right. So let's read this and make sure it makes sense. This parses those second set of ones. Found slash the format list cannot end here. Either specify another format or remove the slash. Right, it's just binary, right? Okay, well, it's the same. No formats found. These are the options. Binary slash text. Binary slash text. Should have the same format. Should not have the same format specified more than once. Yep, cool. So now after we've parsed all this, so let me put a thing here. This is the target directive. So we can skip this body of code, no problemo. It's kind of big, but it's only used once. There's no point really sticking it in another function, really. You know, you have to chase code everywhere, and it's... right, so if you... So text is only available for when file is specified. I think that's the only rule. So if file... so if it has text and target flags is not got file. Would we say that's right? Yeah. You would just say like target directive cannot have text. No, but you can't have text if you've got GPU. So let's look at the format thing. Where is it? There's a text mode. Feature, what is that? Right, features. CSON. So that's text. I should really call it text CSON. Let's change that. No, I'm already in there. Great, so corrected that. So yeah, it says it's enabled with file, but if you have, it's unsupported on GPU. It does kind of scream it in your face, this, doesn't it? I don't know. Anyway, yeah. So if you have text and it doesn't have file, or and it doesn't have file, or it has GPU, it's an error. Target cannot have text, cannot be text, or have a text format if file is specified. We should do it separately. It's too smart. Too much smartness in one area. Let's join up a little bit. Cannot, the target directive does not have, can I have a text format if the file target is not specified. So you'd be like target file text. Right. Nice. Now your next one. Maybe I should join some of these lines up. I know. The next one is saying if it has GPU, then that's a problem. If GPU target has been specified. So you would then say file and text, I guess. There you go. Cool. Right, so I think those are the only checks that you need to make. I don't think there's anything else. Oh no, there is. Well, no, text is directly enable, right? Features, VLAs. Well, VLAs are not specified via that target mode thing. Only text was. Versioning, right? These features probably need to be put in as well, right? Yeah. So what we need to do is write these features in. If I would say feature for VLAs, a target feature for text, versioning upgrade, packed stuff, non 4-byte types, right? If you're on GPU, we disable anything else other than 4-byte types. Pointers. Yeah, same thing. So that way we can just say, oh, if pointers are enabled, you know. Yeah, just be a bit easier rather than doing the checking. Yeah. So these are the feature flags. So feature flags like so. From the top, VLAs. VLA, text, versioning, version upgrade, packed type, wait. Oh, not packed types, packed, the packed attribute. Or the packed thing. It's not supported on GPU. And then the other one is non 4-byte. Are these just available on all of them, but GPU? So I guess feature flags would be, we could maybe put it under the same umbrella, because packed non 4-byte types or whatever. Maybe we should say, a real computer, because like we could put a bunch of different flags, but each. I guess we could all of a sudden enable non 4-byte types and change that to being like, well, we support 16-bit types or whatever, because some GPUs, you might change our compatibility or something. So I guess maybe it's good to put it at the per feature level. So yeah, one's packed. The other one is non 4-byte types. The other feature is pointers. So let's get all these boys and girls aligned. All right, let's plop that in there. Oh, there we go. 2 and 4, very nice. Oh, these should have totally been doubled. There we go. All right. So all our flags. These are the feature flags. So we'll make sure that the feature flags are obeyed at some point, but we can at least get them configured today. Oh. Target feature flags. So let's get all those in. Quite easy. So the bottom here, after we've parsed it, done all the verification, the validation, whatever you want to call it, we go right. If enum format flags doesn't line up and down. Now, doesn't it? Oh yeah, it's not aligned, is it? Nowadays, is my alignment different for each of these? There we go. My room is now clean. So this is where we want to, let's get each one of those flags actually, and we'll fill them all in. So, right, VLAs. VLAs are enabled if you have file, but if you have GPU, it's unsupported. Yeah, so it's a similar sort of thing here where it's like, the other way around. All right, let's do this. So if you have file, and you don't have GPU, it's your lucky day. You've won yourself a target flag, feature flag. Target feature flag, VLA. Cool. Next one, text. Text is probably the same thing. Yeah, text is the same, right? It's unchanged for networking, but it's enabled when you have file. Right. Pretty nice. We'll keep them separate, I think, because maybe things can change. Maybe. Maybe not. Now things change. Yeah, let's just make it neater, right? If not, I can just go on for ages. Versioning. If you have file or network, you get versioning on. If you just have file, you've got yourself versioning upgrade. Yeah, I think we'll do file or network. We've got versioning. If you just have file, you've got yourself version upgrade. Maybe it's on a separate one. You know what? Version upgrade. But if you just got networking, that gets you a bit of versioning. Yeah, code has, that's right. Yeah, will not compile. The next person who read this will, yeah, they will turn ill. Complete hazard. Upgrading, packed. Right, so this is where it's now. If it's not GPU, it turns on. So, well, that ended that one. Right, so the final one, if it's not GPU, we get to turn on all lovely features such as packed stuff. What would I be if you... Yeah, I think that works out. So, yeah, non-4-byte types and pointers. So, your target flags, you always have to have at least one, right? So if you specify just GPU, this will never turn on. If you specify GPU and something else, then these will never turn on. That's right. It's cool. If you specify something else, you'll get that. Right. That's it. So that's our feature flags all done. So in future, when we want to simply check a feature and do some logic, we've got these guys. Hey Lupo, how you doing? Welcome, welcome. So that was the target directive thing. Quite a lot of code there, but it should work first time, right? Now the next one is if file feature flags, sorry, target flags and target flag is a file, you need to provide, according to the documentation, a magic number. So it gets a bit of hex parsing, I think. And we should really be supporting comments. But we don't really support comments. Yeah, it kind of sucks. Well, since we read the whole file in, we could do a parse over the whole file, get rid of all the comments, and then carry on with our lives. But yeah, I'm using a a text reader, because it was just quicker to write the parsing code. But yeah, obviously it has small little problems like white space, but now this comment one is probably a bit bigger, because every place where you're at, we could probably class it as white space. I don't know. Maybe. How's it going? Doing alright. Yeah, we're just executing on the big old plan now. Designed out the encoder system fully. Everything's been logically thought out. Well, nearly everything. All the main big things been thought out, and all makes sense. So we're just executing on the plan now, taking it to completion. Some funny thumbnails. What's up with my thumbnails, huh? They look alright, don't they? What's wrong? I don't know what my stream looks like, actually. Yeah, so if I were to parse the magic. Yeah, there's these comment things which get a bit weird. I would like the idea of comment. You really need to deal with comments. Huh. Because the problem is we do like read until on a lot of things. So when we do this read until new lines, you've got to do like maybe a slash, and that'll read up until the the comment thing. The single line comment. And then yeah, you just gotta handle it in all these places. It's a little weird, to be fair. Yeah, maybe in retrospect we shouldn't have just rushed it and done a proper Lexa. Because comments will be kind of nice, but maybe you just can't put comments anywhere. And they have to be in certain places that we just handle. Maybe that's what we'll do. But yeah, I'll put that as a thing to do. Comment support in most places. Smiley face. That'll to solve the problem. But yeah. So if it's a file, we want to parse a magic number. So we need to do something like this logic here. And we just want to parse a number. So the directive we're looking for is magic directive. Expected magic directive to follow the target directive on the next line. Since file target was specified. So you'd be like, new line. 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5, 6. Hash. Magic What was the example? Oh yeah. Look at that. It's gonna be legit. We'll do that. It's all good. Good to hear. Can you please clarify what you mean by my thumbnails? How are my thumbnails always a bit funny? Which ones? Are you talking like on YouTube or like on Twitch when you see me streaming? Right, let's put the magic directive in, skip a little bit of white space. We then want to parse a number. Now the number should be in hexadecimal. You know, because hex is the way. So what we're going to be doing is just checking that there is 2 characters here. For 0x, I reckon. So we can do parse num. So what happens if you don't parse a number? Is there anything? So it does some checking, multiple decimal places, just verifies everything. Some suffixes and things. Okay, expected a number. Screw it, we'll take in a whole number. So pass in the reader. What's the basic type out? Value. Nice. Is there like an expected on there somewhere? No, okay. So basic type. And then value. So with these 2 things here, we now have parsed up the number, so it has to be an unsigned int. So if basic type class basic is not equal to basic class of uint, then we simply say the magic number must be a uint, right? Preferably hex. Makes more sense that way. The magic number must be... It also has to be within the range of a 32-bit int as well, right? Wait, let me check that packed thing for a minute. Verify basic value, to make sure it doesn't go out of bounds. That's good. Right, but I messed it up. Because I changed some damn code. Expected basic type. Verify that the value fits within the range of the expected basic type. So the expected basic type is a 1-byte integer. Make sure the value doesn't exceed that 1-byte integer. Yep. Right, I'm glad I sort of remembered that. That was weird. Right, so in parsing the number, so we have got that expected thing as well, isn't it? That function we just saw, so we can use that. The magic number must be an unsigned uint, or must be a uint but got, you know, this instead. Then we do a hint. So type basic type or class strings, basic type class basic. There we go. So it prints out as a nice string. Now the other one we want to do, nearly there for this one. We're making sure that this one is a there's a verify English. There we go. Verify basic value, passing the reader, passing the basic type we expect it to follow. So in this case, it will be a U32. And value. So the value is that one. So magic number must fit within a U32. We got a value of, we got the value this. So in that case, we'll just put something like value.uint, the one that we parsed. Nice. So I think that's pretty good. What are we missing? Oh, does the verify not return a boolean? Whoops. Right. Okay, it does it all for us apparently. I can't give a more detailed error message, but that's okay. Past Henry, eh? What has he done? Cool, so that should be parsing that. The thing is though, the magic number has to go somewhere. If not, we've just parsed it for some reason. So U32 magic, bit of magic. So for the file, the magic number. So in that case, it'll be file magic equal value.uint. Very nice. Yeah, so that's cool. Right, so what else have we got left to parse? There are quite a few little things. We still do support for unions and get rid of tables. We've still got to do unions and get rid of tables. We've got to parse up a bunch of little directives, and we've got to ensure that we can parse different versions of the same structure in a different way to the way we've already done it. So those are the things that we're going to be doing next time, I think. I think we've reached a good place to end. Yeah, we made some progress today at least. Managed to parse this. Well, I haven't tested it, but we've written the code for it. Yeah, we still need... Yeah. That's right. Cool. Right. So then we'll put a pin in it there today. So next stream, I guess we'll carry on with this sort of parsing stuff, you know, making sure everything parses up correctly, and maybe get around to starting testing some of it at least. But yeah, that'll be on Sunday. at probably, yeah, 4 hours ago, but on Sunday, and then like three, well, yeah, I guess 2.5 hours ago, but on a Tuesday and Thursday next week. Right, let's find someone to raid. Um, hmm. All right, it's raid Last Miles. All right, guys, thank you for coming. I'll see you all in the next one. Have a good start to your weekend. And yeah. Yeah, doing good, man. Doing good. Yeah, doing alright. We got the encoder system all planned out now. Got a nice documentation file. Just planned it all out, all the specifics about it. But yeah, just on the final stretch now of getting this system done and making sure all the boxes are ticked that we've laid out basically. But yeah, it's all good. Right, it's gonna raid. Cool. Anyway, I'll speak to you some other time. Catch you later. Have a good such weekend. Bye bye.